Hello everyone, I'm going to be solving the lecture questions for you in this video. So let's get started. So which of the following is not possible for the image formed by the lens in the accompanying figure? So my figure is basically the lens, and this lens is going to have thin at the edges and then it's going to be thick at the center. So we are talking about basically convex lens or converging lens. So once you look at it, you need to go to page 32 and then you're going to be able to see all of the properties that you can have with this lens. So let's see which of the following is not possible. So let's see the first one, virtual and smaller in size. So virtual is going to be one option for us. So to be able to create a virtual image, you need to basically look at the last one. So if an object is closer to the focal point, then my image will be virtual. But once you are closer than the focal point, the image is virtual, but it's never smaller. It's always larger, and if you actually also think about it, it's going to be behind and it's going to be larger. So basically in this case, A will be the answer. But if you also look at the other ones, page 32 is going to have all of the possibilities. This is going to be beyond the center. This is going to be in between center and focal point, and this is going to be closer than the focal point for those B, C, and D. So your answer is A. Next one, that looks a little bit confusing because it has a graph, but what we need to remember is this math part, 1 over SI plus 1 over SO. Actually, all we have to do is look at the graph and then pick one of the points actually. So the easiest one I think is this one, because here we have 1 over SI and 1 over SO values already. So if you look at it, then your 1 over SI at this point is 1, plus 1 over your SO is also 1. So 1 over focal point is equal to 2. So then 1 over focal point is 2, and what does that mean? You need to flip both sides. F equals 1 over 2, and that means your focal point is 0.5 meters. So you don't need to do much of a math. All you have to do is just recognize that you have x and y's, and then you have 1 over SI and 1 over SO's in those axes. So you just need to plug it in those values, and you can just plug in any numbers. As you can see, this is 1 over 1.5 and 0.5, so addition is still 2, so it's always going to give you 2. So your answer is again A. Alright, a coin is 12 centimeters in front of a converging lens with focal length of magnitude 4. Where's the image? Alright, so in this one we're going to need to basically do the math. So 1 over focal point is equal to 1 over SI plus 1 over SO. So all we have to do is just plug in all of the numbers into the equation. So this is 12 centimeters. That's where the object is. So 1 over SO. So my SO is 12. So focal length is 4 centimeters. And we are talking about converging lens, so it's not negative. Remember, if it was a diverging lens, then focal point for a diverging lens would be negative. But there's nothing negative, so this is 4, this is 12, you're looking for this, so we just need to plug in all of the numbers that we know and then just solve the equation. So 1 over 4 equals 1 over SI plus 1 over 12. So the fast way of doing this, you basically subtract 1 over 12 from both sides. Then 1 over SI will become 1 over 4 minus 1 over 12. And at this point we have 4, 12, so we basically need to have the common denominator, so we need to multiply this guy with 3. Then 1 over SI will become 3 over 12 minus 1 over 12. And if you redo this, then it's going to be 3 minus 1, which is 2 divided by 12. So then the final case will become 1 over SI equals 2 and 12. They will be simplified as 1 over 6. Then 1 over SI, 1 over 6, 1 equals 1. That means SI is equal to 6. So location will be 6, but you have two 6 answers basically. So where is it going to be? Is it going to be in front of the lens, or is it going to be behind the lens? So again, if you check the page 32, you will be able to see for objects that are in front of the lens, they're going to actually have their images in the other side, like on the right side of the lens, and that's basically considered as behind the lens. Alright, so an object is located 0.2 meters from the converging lens, which it has a focal length of 0.15 meters relative to the object. The image formed by the lens will be. Alright, so in this case, we don't need to do math again. You're going to check page 32 and you're going to figure out where the image is, where the object is, and what are the properties of that case. So we are given the object at 0.2. So object is at 0.2. And then we are looking at the converging lens, and the focal point of this lens is 0.15. So this is the focal length. That means my center of curvature will be at 0.3, because remember, focal point and center of curvature, basically 2 times focal length is going to be your center of curvature. So my object is technically in between focal point and center of curvature. Again, go ahead, check page 32, and then you will be able to see all of the properties of this object. If an object is in between center of curvature and the focal, the object is going to have real image, it's always going to be inverted, and at this point it's going to be also larger. So real, inverted, larger, so your answer is C. So as you can see, I always look at, give the reference of page 32, so you always need to figure out, know properties of all of the images depending on where the object is located. And the last question, a diverging lens. So this time we're going to be talking about diverging lens. We're not going to have much of a question about diverging lenses because it's the simple one. So what is the question? Diverging lens produce an image of a real object. So for diverging lenses, we will only have one image, and that's basically going to be on 34, I believe. So it's always going to be virtual, so there's no real. It's always smaller, and it is always upright. So your answer is B. So as you can see, these are all about the properties of the images, and most of the questions that we're going to have on the test will also be about that. So we will also have the math parts, but the main thing is about properties of the images. So please look at page 32 for the lenses, and then try to figure out all of the properties, and at least know where you're going to be able to find the answers for the questions. Alright, thank you so much. We're going to see you in the next videos.